Good morning students, welcome back to the lecture number 13 of chapter 7. So in this lecture we are going to solve 2 to 3 questions from the same exercise number 7.2. Let's start with the question number 2. So in question number 2 it is given in triangle ABC. Let us first draw a triangle ABC. Okay. As soon as you read the question you have to draw the diagram. So you have to draw a triangle ABC. Now in this triangle AD is perpendicular bisector of BC. First of all, you have to understand AD is the bisector of BC, right? So bisector means it divides BC into two equal halves. Suppose this is the bisector AD, which divides BC into two equal halves. That means this half is equal to this half. This is clear. And another term is there, perpendicular bisector. Perpendicular bisector means it divides BC into two equal halves at an angle 90 degree. Okay, this is the meaning of perpendicularity. So it divides or it makes an angle 90 degree with BC as well as it divides BC into two equal halves, so that BD is equal to DC. This is clear. So write what are the given in the question. So it is given that BD is equal to CD. Why? Because AD is the perpendicular bisector. Okay, this is the meaning of perpendicular, right? And AD perpendicular on BC. Understood? Now from this data we have to show that to prove or to show triangle ABC is an isosceles triangle. Okay, so ABC is an isosceles triangle in which two sides are equal? AB and AC are equal. So we have to show that ABC is an isosceles triangle having AB and AC are equal, right? So let's prove. In order to prove ABC is an isosceles triangle, we have to choose two triangles. Which triangle? The triangle ABD and the triangle ACD, and compare them. Okay, so let's compare. Comparing triangle ABD and triangle ACD. Okay, so first condition is in ABD triangle, BD is equal to in ACD triangle, CD, BD is equal to CD. Why? Because it is given BD is equal to CD. Right? So you can write BD is equal to CD. Okay, why? Because AD is the bisector. Bisector of BC. Clear? Second condition is in triangle ABD, this angle is 90 degree, and in triangle ACD, this angle is 90 degree. So this angle is equal to this angle. ADB is equal to ADC is equal to 90 degree. This is given because it is perpendicular. So ADB is equal to ADC is equal to 90 degree. This is given. Or you can write, why? Because AD is perpendicular on BC. Third condition is considering ABD triangle, then AD is a side of this triangle, ABD triangle. Similarly, this AD is another side for the triangle ACD. So AD is the common side to both the triangle. AD is equal to AD, common side. Okay. So these are the three conditions that you find. You find which is condition? This condition stands for S. This AD stands for another S. Now this stands for angle. So side, angle, side. Similarly for this triangle also side, and angle. So by SIS criterion or congruency, this two triangle becomes congruent. Hence, by SIS congruency, triangle ABD is congruent to which triangle? Triangle ACD. Okay, now we have proved that these small two triangles are congruent. Okay, now if two triangles are congruent, then their corresponding parts, that means their corresponding sides, their corresponding angle must be equal according to axiom 7.2. So here also, this small triangle is congruent to this small triangle. Now we can write that this AB is a side of which triangle? ABD triangle. Okay. Similarly, AC is a side of which triangle? ACD triangle. Since this triangle and this triangle are congruent, so we can write this side is equal to this side. AB is equal to AC. Understood? So AB is equal to AC, hence by axiom 7.2 or CPCT. Clear? Now what we find? We find in this triangle ABC, AB is equal to AC. We have found this side is equal to this side. It means what? It means it is a which type of triangle in which two sides are equal. So it is a type of isosceles triangle. Hence, ABC is an isosceles triangle with this side is equal to this side, and it is proved now. Understood? Moving to the question number 3. Right. In question number 3, the statement is ABC is an isosceles triangle. Right. So ABC is an isosceles triangle ABC. And later on it is given that there are two equal sides, AC and AB. So this isosceles triangle has two equal sides, AC and AB. Later on it is given AC and AB. Clear? So given ABC is an isosceles triangle with which two sides are equal? AB and AC are equal. Now ABC is an isosceles triangle in which altitude B and altitude CF, there is a term, see, altitude. Let us understand what is the meaning of this term altitude. Okay, there are two altitudes. One is altitude B and other is altitude CF. So what is the meaning of altitude? Altitude means perpendicular on, okay, perpendicular on any line. So what is the meaning of altitude? Altitude means perpendicular. For example, suppose this is a line AB, and on this line another line CD is perpendicular. So how we write? We write CD is perpendicular on AB. We write like this. Yes or no? It is also known as perpendicular means altitude. So we can also tell as or called as CD is an altitude to AB. Understood? So altitude means perpendicular. That's all. Understood? For example, this is a line MN. Now to this line another line OP is perpendicular. So it means what? It means OP is perpendicular on MN. Or you can write OP is the altitude to MN. Understood? So the literal meaning of altitude is perpendiculars. This is clear. So in this figure it is given that there are two altitudes. One is altitude B, other is altitude CF. Understood? And B is altitude or perpendicular to which line? To AC side. Okay. B is perpendicular to AC sides and CF is perpendicular to AB sides. Understood? So B is perpendicular to AC and CF is perpendicular to AB. Here, so let us draw BE. B means it will be started from B, which is perpendicular on this side, right? So suppose this is perpendicular, right? So BE is perpendicular on AC, clear? And CF, suppose this is CF. Now this is perpendicular on AB. Understood? Now this is clear. So it is given that BE is perpendicular on AC and CF is perpendicular on AB. This is clear now? Okay. Now we have to prove that BE and CF and BE are two what? Are two perpendicular, or they are known as altitudes, right? Now we have to prove that these altitudes are equal. What are the altitudes here? Here BE and CF and BE are two altitudes, and now we have to prove that these two altitudes, these two perpendiculars are equal. So we have to prove BE is equal to CF. Are you getting my point? Altitude means perpendicular, right? So let's prove. In order to prove this, we have to choose any two triangles. Which two triangles? Now tell me, B is a side of which triangle? See, BE is a side of which triangle? Tell me. It is a side of which triangle? This triangle. Which triangle? BEA. So we will compare between triangle BEA and tell me CF is a side of which triangle? Which triangle? This triangle, isn't it? This triangle. CFA. Triangle CFA. Understood? So we will compare this small triangle with this small triangle. Okay? So let's compare them. First condition. In this triangle BEA, in this triangle, this angle is 90 degree. Yes or no? Yes. Similarly, in this triangle, in this triangle, this angle is also 90 degree. Again, I am drawing it so that it is easy to understand. We have chosen this triangle. In this triangle, this is B, this is A, this is Z. In this triangle, this angle is 90 degree. Clear? Similarly, in this triangle, which triangle? This triangle. Okay, this is C, this is F. This angle is also 90 degree. So you can write that this angle is equal to this angle. Understood? Don't be confused. So this angle means angle BEA is equal to this angle means CFA. Why? What is the reason? The reason is that BE is perpendicular on AC and CF is perpendicular on AB. Or you can say these two are the altitudes. Now coming to the second condition. See, if we consider this as a triangle, then this one is an angle. This is the angle of which triangle? BEA triangle. Yes or no? Yes. This angle is named as BAE. Okay. Or you can say simply A. So A is an angle in which triangle? BEA. Now, if we consider this as a triangle, this. Understood? CFA. Now, in this triangle, this is also an angle. So, A is also an angle of CFA triangle. Now, what we find here? We find that A is the common angle to this triangle and to this triangle, to both the triangles. Understood? So, we can write that angle A is equal to angle A, that is common angle. Now third condition. What is the third condition? If we consider this triangle BEA, right? Then AB is a side. of triangle BEA. And if we consider this triangle CFA, then SE is a side of triangle CFA, isn't it? But given that AB is equal to SE, AB is equal to SE, it is given. Why? Because ABC is an isosceles triangle, and in this triangle AB side is equal to SE side. So can we write AB is equal to SE? Yes, you can write. Right? AB is equal to SE. Okay? What is the reason? The reason is that given or triangle ABC is isoscale. You have to write the reason. Okay? Now, what we get here? What are the three conditions here? For this triangle BEA, we have found this angle, angle, and this side. Tell me, to which congruence it satisfies? Angle, side. This is not the included side. This is the non-included side. So it satisfies angle, side congruency. Hence, by angle, side congruency, this small triangle BEA is congruent to the triangle CFA, because in CFA also we have taken this angle, this side, angle, side. Okay, so we have proved that these two triangles are now congruent. But what do we have to prove? We have to prove their altitudes. BE is equal to CF. Now tell me, according to the exam 7.2, we know if any two triangles are congruent, then their corresponding sides must be equal. Right? Now, BE is a side of which triangle? BE is a side of which triangle? Tell me. BE a triangle. Similarly, CF is a side of which triangle? CF a triangle. Yes or no? Yes, but what we have found? We have found that these two triangles are congruent. Hence, we can write that their sides must be equal. Implies BE is equal to CF. Understood? This is by exam 7.2 or CPCT. And B are known as the altitude. CF is also another altitudes. Hence, you can write BE and CF altitudes are equal. Okay. So the literal meaning of altitude is perpendicular, and we have shown that two perpendicular distance are equal. Coming to the question number 4. In the question number 4, it is given that ABC is a triangle, right? It is simply given ABC is a triangle. It is not given that ABC is an isosceles triangle. No. Simply you have to draw a triangle ABC, not an isosceles triangle. Okay? A triangle ABC. Now in this triangle, two altitudes. Altitude means perpendicular. What are the altitudes? One is BE and other is CF. Understood? So BE and CF are two altitudes here. Now it is given BE is an altitude to which side? AC side. So BE altitude means perpendicular to AC, and CF is altitude to which side? To AB side. So CF is perpendicular to AB. This is given. So let us draw this figure. BE, suppose this is BE and BE is perpendicular to AC, clear? And CF is also perpendicular on AB. Understood? Now it is given two altitudes BE and CF to this and this are equal. So which are equal? These two sides are equal or these two altitudes are equal? Understand this sentence. Two altitudes BE and CF which are perpendicular to AC and AB are equal. So these two altitudes are equal, not these two sides. No, these two altitudes BE and CF, these two are equal. Okay, and BE is equal to CF. This is given. Now from this data we have to prove two statements. The first statement is triangle ABE is congruent to the triangle SCF. ABE triangle, ABE, this small triangle is congruent to the triangle ACF. We have to prove this, and secondly we have to prove that AB is equal to SC. AB is equal to SC means what? AB is equal to SC means what? It means ABC is an isosceles triangle. We have to prove this. ABC triangle is isosceles. So let us prove the first statement. In the first statement, we have to prove that ABE triangle is congruent to SCF triangle. So let us compare them first. So between triangle ABE and triangle SCF, since it is given BE is equal to CF, it is already given. Don't underestimate it. It is already given. Okay, B is equal to CF. Now we will compare this. See, if we take this triangle ABE, this triangle, then in this triangle this angle is 90 degree. Similarly, if we take this triangle SCF, now in this triangle this angle is also 90 degree. Okay, so this angle 90, this angle 90. This angle means AEB. So first condition is AEB is equal to this angle, means AFC is equal to 90 degree. Why? Because BE is perpendicular on SC and CF is perpendicular on AB. This is given. Second condition is, if we consider this as a triangle, then this A is an angle of this triangle. Similarly, if we consider this SCF as a triangle, then this is also an angle for this triangle. So A is the common angle to this triangle to this triangle. So you can write A is equal to A common angle. Third condition is, in the triangle ABF, this side BE is equal to, in the triangle SCF, this side CF, BE is equal to CF. It is given. Okay, so B is equal to CF. It is given. So what are the conditions we have found here? We have found for the triangle ABF this angle, and this side. Similarly, in this triangle, this angle, and this side. Then tell me, it is ASA congruency or AAS congruency? See, for the triangle ABF, it is A, and this is non-included side. So AAS congruency. Hence, by ASA congruency, triangle ABE is congruent to the triangle ACF. Okay, so by by AAS congruency, these two triangles are become congruent, and we need to prove it for the first statement, and it is now proved. It is now proved. Proved for the first statement. This is clear? Okay. Now let us move to the second proof. Now for the second statement, we need to prove AB is equal to SC. AB is equal to SC. How can you prove it? See, as we have found that this small triangle is congruent to this small triangle. Now as for the exam 7.2, if any two triangles are congruent, then their corresponding sides must be equal. And AB is the corresponding side of which triangle? ABE triangle. And AC is the corresponding side of which triangle? SCF triangle. But what we have proved? We have proved that these two triangles are congruent. That means we can write that their corresponding sides must be equal. So AB is equal to SC. CPCT. Understood? We have found AB is equal to SC. Ultimately, we can say yes, ABC is an isosceles triangle because its two sides are equal. Hence, ABC is an isosceles triangle. Understood? So, question number 3 that we have done previously and question number 4 are converse to each other. In question number 3, it is given that ABC is an isosceles triangle in which AB is equal to SC, and we have proved that their altitude B and CF are equal. But here it is given that altitudes are equal, and we have to prove that AB is equal to AC, or ABC is an isosceles triangle. Now we have proved it. It is an isosceles triangle. Okay.